We are going to be looking at how to solve a quadratic equation by the method of completing the square. And we will be taking two opportunities to review this process. So part one as well as part two. So reminder, let A, B, and C represent real numbers where A is not equal to 0. So a quadratic equation in the variable of x is an equation of the form a times x squared plus b times x plus c, and this is set equal to 0. And because the degree of this equation is 2, a quadratic equation will always have two solutions, but those solutions may be real or imaginary. Now, we have already tackled the process of solving quadratic equations by using the square root property. And the method of solving quadratic equations by completing the square actually uses the square root property as well. So we're going to have to remember what that entails. So if x squared equals k, remember that is quadratic because the highest exponential power is 2. Therefore, we're going to have two solutions. So x will equal the positive square root of k as well as the negative square root of k. So in order to use the square root property with a quadratic equation that is not in the form of x squared equals k, we must create what is called a perfect square trinomial. And a perfect square trinomial comes from one of two forms. Either, let me get into pen mode, either x plus a value, a, quantity squared, which means x plus a times x plus a. And if we distribute, this results in x squared plus x times a plus a times x, which are the same, so we have two of them, so plus 2 times a times x, and then finally the last distribution gives us plus a squared, and this is what we call a perfect square trinomial. Trinomial meaning three terms. Perfect square because when we factor it, it is a binomial times itself, a square. So then the other form can be x minus a quantity squared, which is going to give us almost the same outcome, but this time we have x minus a times x minus a. This still produces x squared, but because of the subtraction, we have minus x times a, and then minus a times x, which combines to be minus 2 times ax. And then finally, a negative times a negative is a positive, so this gives us plus a squared. And this is also a perfect square trinomial. So what we're going to first work on together is determining the value of n in order to create a perfect square trinomial. Now remember, a perfect square trinomial factors and produces a quantity squared. So x squared is simply x times x. Now notice we have plus 10x and we have plus n, and we're looking for that value of n that is going to create a perfect square trinomial, that is a binomial times itself. So 10 is going to guide what we need to do in order to determine n. So this is a bit of a riddle. We want to know x plus what times x plus the same what is going to give us 10x. Well, x times x is our x squared. So now we want to figure out what goes here that are exactly the same numbers that is going to add to be 10x. So they have to be the same. but they're going to add to be 10x. So if it has to be the same, and there's two of them, don't we want to split that 10 in half, giving us a 5? So 5 and 5. Does that indeed give us 10x? Yes, it does. And then if we think about finishing this distribution, this is new for us. We now have 5 times 5, and that is our n. That is what creates our perfect square trinomial of x squared plus 10x plus 25, which factors as x plus 5 quantity squared. So again, we're looking for two factors of 10, or pardon me, looking for two factors that add to 10. And so factors that add to 10 are 5 and 5, and 5 times 5 is our 25. That's the number that we're looking for. For our next example, we have two differences here. First, let's notice that we have minus 9x. Secondly, let's notice that 9 is not an even number. So if we look back to this example, 10 was an even number, and so when we take 10 and we split it in half, half of 10 is 5. But we can do the same thing here. Okay, so we're going to get started with beginning to factor this. So because this is minus 9x but plus n, this is going to factor as x minus and x minus. So again, we're looking for two factors that add to negative 9. And those two factors need to be the same because we want to create a perfect square trinomial. So we're going to take this negative 9 and we're going to split it in half. Another way to think about this is we're going to take half of negative 9, and that is negative 9 over 2. So we have x minus 9 halves, x minus 9 halves. And I want to actually show you the full distribution of this to make sure we understand why the negative 9 halves. So if we distribute here, we have x squared minus 9 halves times x minus 9 halves times x, and then plus 9 halves times 9 halves is 81 over 4. Now here, these are going to combine, and so negative 9 halves minus 9 halves is negative 18 halves, which is the negative 9 that we had originally. And now we're actually able to see what our n is that gives us our perfect square trinomial. So n is 81 over 4, and this in factored form is x minus 9 halves quantity squared. So this is a very important step right there in order to factor this as a quantity squared. Our next example, we have x squared plus, so this is going to give us x plus times x plus. And so now I need to focus on the 4 over 9. So we're looking for two factors that add to 4 over 9. So I need to take that 4 over 9 and I need to split it into two pieces. And therefore, I need to take 1/2 of 4 over 9. Now notice we have a denominator of 2 but a numerator of 4, so that is going to cancel and give us 1 times 2 over 1 times 9, or 2/9. And so we now have that number to fill in our missing piece. And when we distribute here, we have x squared plus 2/9 x plus 2/9 x plus, and let's think about what 2/9 times 2/9 is. So we multiply our numerators, we multiply our denominators, and we have 4 over 81. And then here, 2/9 plus 2/9, we have a common denominator, and so we add our numerators, which produces 4 over 9, which is what we had originally. Both are times x, and we have that missing piece, 4 over 81. So n is 4 over 81. That was the piece we needed in order to complete our square, which creates a perfect square trinomial, which factors as x plus 2 over 9 quantity squared. Your first questions. You're going to determine the value of n that makes the polynomial a perfect square trinomial. So you are trying to figure out how to factor this so that it will create a quantity times itself. And remember, the key is looking at that number and paying attention also to the operation in front of it. Is it plus or is it minus? And your next question, x squared plus 15x plus n. So you're trying to figure out what is n, so that when you factor this, it is going to create a quantity squared. So now we're going to actually take the work that we've been doing and use this to solve a quadratic equation by the method of completing the square and then applying the square root property. So the first step we're not going to have to utilize for our first two examples here, because a will be 1. We'll see that. But then step 2, we will always have to make sure that the variable terms are on one side of the equation and the constant is on the other. And then we're going to follow the steps to complete the square. So we're going to take 1/2 of the linear term coefficient. We're going to square that, and then we're going to add it to both sides. And then we're going to factor the resulting perfect square trinomial so that we can apply the square root property and solve for x. So let's dive right into x squared minus 8x minus 9. So notice a is equal to 1, but now we need to make sure that our variable terms are on one side, but our constant is on the other. And I'm going to leave a space so that we can complete the square. So x squared minus 8x, we're going to leave a space here so that we can complete the square, create a perfect square trinomial. But I want my constant on the other side, so I'm going to add 9. And now we're going to complete the square. So I need to recognize that my linear coefficient is -8. And so we're going to take half of that, and half of -8 is -4. And then following the steps, we're going to take that value and we're going to complete the square by squaring that value. And a negative squared is a positive. So negative 4 squared is positive 16. And we're going to add that because it is positive. And keep our equation balanced, we need to add it to both sides. Now the left-hand side is our perfect squared trinomial. It is x minus 4 times x minus 4. And notice our right-hand side we can simplify to be 25. Now we're going to notice that 25 is going to be very important to us. Notice it is positive. Also, please notice it is a perfect square. So x minus 4 times x minus 4 is x minus 4 quantity squared. And now we're applying the square root property. So we're going to undo the square by taking the square root of the left side. But then remember this is quadratic, so we have two solutions. So we're going to take the positive and negative square root of the right side. So x minus 4 is equal to positive or negative. And because 25 is a perfect square, the square root of 25 just gives us 5. And then finally, we need to solve for x. So we need to undo the subtraction of 4 by adding 4. So x is equal to 4 plus or minus 5. So we need to separate. So x is equal to 4 plus 5. X is equal to 9. Or x is equal to 4 minus 5. X is equal to negative 1. And notice, please, that our solutions here are not only real, they are also rational. So we have real and rational solutions. Our next example, we have a little bit of work to do here. The first thing that I would encourage you to do is notice that we have a variable term on both the left side and the right-hand side. So we want to get our variable terms on one side. So I'm going to add 8x. And then we want our constant on the right-hand side. So I'm going to leave a space here. And we're going to add 2. So now we're focusing on b, and b is 8. So we're going to take 1/2 of 8, which is 4, and 4 squared gives us 16. And so this tells us what we're going to add to both sides in order to complete the square. Excuse me. So the left-hand side factors as x plus 4 times x plus 4. Notice this comes back into play, doesn't it? And this is equal to 18. The left-hand side factors as x plus 4 quantity squared. And now we're going to apply our square root property. We're going to take the square root of the left side to get rid of that square power. So we have x plus 4. And because this is quadratic, we're going to take the positive and negative square root of 18. So x is equal to negative 4 plus or minus the square root of 18. But we are not done here. You're always going to be asked to simplify fully. And while 18 is not a perfect square, it does factor as the product of 9 and 2. So x is equal to negative 4 plus or minus the square root of 9 times 2, or negative 4 plus or minus 3 square roots of 2. And we do have two solutions here. I'm just going to separate them. X is equal to negative 4 plus 3 square roots of 2, or x is equal to negative 4 minus 3 square roots of 2. And note that our solutions are real, but because we were not able to get rid of our radical, they are also irrational. And what really drove that fact is the number 18. 18 is not a perfect square. So your last question to tackle is you're going to solve by completing the square. And notice your variable terms are on the left side and your constant term is on the right. So you are in good shape to be able to solve this.